Hello everyone, I am Pranav. I am accompanied by my co-author Jayant and Pishreddy. We are going to present our paper titled FPGA Implementation and Acceleration of Convolutional Neural Networks. Ranjita and Professor Rajeshwari are co-authors of this paper. The presentation flow for this paper is as follows: motivation, introduction, proposed work, results, summary, and the references. Image processing, image recognition, and classification algorithms are fastest growing fields in engineering and research. Convolutional neural networks are among the algorithms that provide best performance for these algorithms as it does the feature extraction as well as classification. Graphical processing units or GPUs are generally used for the purpose of training, testing, and implementation of these algorithms. The motivation to implement CNN on FPGA for image classification is due to the reduced accessibility of GPUs on embedded platforms. This implementation removes the need for GPU while performing tasks remotely. Introduction: CNNs have been deployed in many fields of image processing and recognition algorithms, but because of computationally intensive convolution operations, they, we require platforms like GPUs for training, etc. However, GPU consumes high power, limits its applications in embedded domain. FPGAs are used in the place of GPUs because of low latency, low engineering cost, high energy efficiency as compared to GPUs. CNN architectures such as LeanNet, AlexNet, GoogleNet, VGGNet are the standard architectures which are used in various other applications. For our work, we have used LeanNet 5 architecture. It consists of 5 layers, that is, 2 convolution layers, 2 pooling layers, and one fully connected layer. CNNs are similar to any other ordinary neural networks with explicit assumptions that inputs are images or video frames. CNN architecture mainly comprises of sequences layers such as convolution layer, ReLU, pooling, and fully connected layer. FPGA implementation of CNN is an active area of research. There are many other techniques shown in the literature, such as use of pre-trained model, implementing parallelism in convolution layer, using many other architectures, and also using stochastic computing, etc. The working methodology. In our working methodology, it consists of two parts. First one is training the CNN model on CPU and storing the train weights, and second is implementing the CNN model on FPGA by loading the stored weights. It is shown in the block diagram here. To train and test the LeanNet 5 CNN model, MNIST digit dataset was used. The training has been done using open source neural network library on Python called Keras, which runs on top of TensorFlow.
So once the model was implemented on the Keras platform, the weights obtained during training were transferred to Vivado XLS. Vivado XLS is a software that enables the designer to focus on the algorithm and larger design problems rather than registers or cycle-to-cycle operations. Um, which can be implemented using high-level coding languages such as C or C++. For the proposed work, the architecture of each layer was designed on at Vivado HLS, that is the convolution layer, pooling layer, and the fully connected layer. The convolution layer had both the convolution as well as the ReLU activation function, and this was implemented such that it could be parallelized. Uh, the convolutions between a feature map and the kernel is independent of the convolution between any other feature map and any other kernel. So this property was used to parallelize the convolutions. It was observed that this said parallelization reduced the time required for the convolution to take place while not significantly affecting the resource utilization. Uh, Once the proposed model was designed, we made a test bench on Vivado HLS, and using that, we were able to test our model uh, with that which was designed in Keras. This table shows the accuracy of 200 randomly selected images from various datasets when tested on Keras and on our model in Vivado HLS. To explain about the speed up, I would like to use LeanIt 5 model. When we use LeanIt 5 model serially, the latency observed was around 12 lakh cycles, but on parallelizing the operations in each layer, we could bring it down to around 4 lakh cycles. This and a maximum of again 12 lakh cycles. This and the difference was due to the clock skew. And once the latency was checked over several images, we could calculate the average speedup as well as the maximum achieved speedup, which were 1.4 and 2.5 respectively. Um, Finally, we also compared the performance in terms of resource utilization of our model and some other models which used parallelization as in literature. So it can be seen that the proposed model uh, uses far lesser number of resources while performing as well as the other work in the literature. So it can be concluded that FPGA implementation and acceleration can be effectively deployed uh, for field use. Um, and it was observed that 2.586 was the maximum achievable speed for our proposed work. CNN on FPGA has a lot of um, applications today with the increase in digit recognition and face recognition systems across the world. It is of great significance. These are the references that we have used. Thank you.